we have laws of logs. If you look on your formula sheet, you will see the laws of logs. That's right here. It says laws of logarithms. It's like has a heading. So here are your laws of logs. So we have to determine the value of each. We talked about this already. How do we do log base 2 of 2 without our calculator? It's just 1. 2 to the power of what is 2? So this one's 1. This one is 2. This one is. If you're asking where this is, it's just flip a couple pages ahead. This one is 4. This one is 5, 6, 7, and 8. So let's look here. People will tell me that log base 2 of 4 plus log base 2 of 8, and then write it as a sum. So they go log base 2 of 4 is 2. Log base 2 of 8 is 3. The sum of that is 5. This is what people will tell me. So if you see this, stop thinking. It's right up here. Log base 2 of 4 times 8. And people want to separate that. They'll tell me it's log base 2 of 4 times log base 2 of 8. Which is not true. If you look at the multiplication over here, log of logs, when you multiply two things, you actually add them. So this, log base 2 of 4 plus log base 2 of 8, it can be written as log base 2 of 4 times 8, which is log base 2 of 32, which is 5. The same answer we got when we added them together. So we'll look down here at this one. Log base 2 of 8 plus log base 2 of 16. What's log base 2 of 8? 2 to the what power is 8? 3 plus 2 to the what power is 16. So I get a sum of 7. If I put them together, because they both have plus 1s in front, this is the key thing. They both have plus 1s in front. Whatever is a plus 1 in front gets multiplied together. So I get a log base 2 of 8 times 16. And 8 times 16 is 128. Log base 2 of 128. You mean why did I move down? Alright. Log base 2 of, I think it's 128, which is 7. I'm skipping because we didn't have notes for 10 minutes. Okay. 3. This is called the multiplication law of logarithms. So if you have log base a of m plus log base a of n, you can write them as log base a of m times n, and it works in both directions. So if I give you two things that are multiplied, you can separate them out by positive 1 logs. Okay? So if we look at this one, we have log base 2 of 15. It is a plus 1, and I put the plus 1 in front for a point. You'll see why. And then I go plus 1 log base 2 of y. So they both have 1s in front of them. They can have plus or minus 1s in front, and they have to have the same base. If that's the case, you can put them together. So I have plus 1 log base 2 of 15, plus 1 log base 2 of y. Then I'll get log base 2. Anything with a plus 1 in front goes in the numerator and multiplied. So I get 15 times y. And then I'm done. So if I have two logs that are added together with the same base, I can put them together by multiplication. Now this one here, people don't spot it, but when I have something with a log beside it like this, I will go 9 times x times y. So when I have anything multiplied together beside a log, I can separate them by addition into and expand them. So log 3, base 3 of 9xy can be expanded to what? Well, it can be expanded to log base 3 of 9. And then because these are all in the numerator, the denominator, you don't even see it, it's a 1, right? So because they're all in the numerator, I can bring them out as plus signs. Plus log base 3 of x plus log base 3 of y. Log base 3 of 9 is what? 2. Plus log base 3x plus log base 3y. Can't make them any more simple. Most people will leave the 9 and the x together and write it as log base 3 of 9x. You have to watch because the 9, the x, and the y are all multiplied separately. So you get 3 logs out of it. Then we're flipping over. Okay, we're going to not do all of these as well. So here we have log base 2 of 8 is 3. Log base 2 of 4 is 2. 3 minus 2 is 1. Now what do we speculate if I have a minus 1 in front? This 4 is going to go where? Not multiplied, but divided. It's a minus 1. So we're going to get log base 2, and now we're going to get 8 divided by 4. Because if it has plus 1s in front, it goes in the numerator. If it has minus 1 in front, it goes in the denominator. So now this is log base 2 of 2. What is log base 2 of 2 equal to? 1, which is what, when I add them separately, or subtract them separately, it's add, oh my gosh, what's the difference of? Okay, let's do 3. Log base 2 of 8 is 3 minus log base 2 of 16, 4. 3 minus 4 is negative 1. Now we're going to try and put them together. So we get log base 2. Now this is a positive 1 in front, so the 8 goes in the numerator, and this is a minus 1 in front, so the 16 goes in the denominator. So I'm going to get 8 over 16, which is log base 2 of 1/2. 2 to what exponent gets me a half? Negative 1, same answer. Right? And we're moving down. So this one is the division law of logarithms, the division law. So I always just say the addition or the multiplication and division can go together. The way I memorize these is I never actually look at the formula sheet. If it has a plus 1 in front, whatever's beside it goes in the numerator. If it has a minus 1 in front, whatever's beside it goes in the denominator. If you get more than one thing in the numerator or the denominator, you multiply them. So let's look at this one here. Log base 2 of 15 minus log base 2 of y. I have to have 2 things happen before I can put them together. I have to have 1s in front, whether it be a plus 1 or a minus 1, and base 2. Right? Plus 1 or minus 1 in front, and then base 2. When I have that, then I can put them together. So I get them as a single logarithm. Log base 2. Where does the 15 go? In the top, in the numerator, because there's a plus 1 in front of the log. Where does the y go? In the denominator, because there is a minus 1 in front. Right? That's it. Now this one, we can expand out because we have a log base 3 of 9 in x. 9's in the numerator, it's going to get a plus 1 in front. X in the denominator is going to get a minus 1 in front. So now we get log base, we could go like this, plus 1 if we want, log base 3 of 9, then minus 1, log base 3 of x. Do we actually have to write the 1s? No, I'm just proving a point. When they're in the numerator, they get a plus 1 in front. When they're in the denominator, they get a minus 1. What is positive 1 log base 3 of 9? 2, because 3 squared is 9. Minus log base 3 of x. The purpose of knowing these laws is so that we can simplify expressions, solve equations, both logarithmic and exponential, and verify logarithmic identities. The first examples in assignment we do involve the simplification with laws. Next page. Okay, there's also the power rule of logarithms. Why does it work? Well, let's see. If I have log base 3 of 2 to the 5, if If I have log base 3 of 2 to the 5, 2 to the 5 just means 2 times 2 times 2 times 2 times 2, right? 2 to the 5 just means 5 2's multiplied. So I can rewrite it like that, correct? So this is the same as this. Now using my multiplication law, I can take this, because these are all multiplied, and separate them out by additions with plus 1's in front. Can I not? We just did that. So I can get plus 1 log 2, plus 1 log 2, plus 1 log 2, plus 1 log 2, plus 1 log 2. I can separate them out as single logs, right? Now, how many 5 log 2's how many, I just gave it that way. How many log 3 base 2's do we have? 5. Good job, guys. How many 5 log is that? Since there are like terms, this can be given as 5 log base 3 of 2. So that's why with logs, we can actually use the power rule. We can take this exponent and we can drop it in front, because when you expand it out, you're going to get 5 log base 3 of 2. So using the power, we can drop it in front. Now think about that. If the number's in front, can we bring it up as the exponent? Yeah, we can drop it in front or bring it up. We will want to bring it up as the exponent if and only if you're trying to put them together. If you're trying to put them together, I need plus or minus 1's in front. Correct? That was my rule, plus or minus 1's. So what if I have a 5? Well, I can bring the 5 up as the exponent, and then I'll have a 1 in front, right? So you need to know that power rule, because we've had 1's until now, all had 1's and minus 1's in front, but what if we have a number? We have to bring that number up as the exponent, and then we'll have plus or minus 1's in front. So that's the rule. So how can I rewrite this if I wanted to? Log base 3 of 9 squared?
2 log 3 of 9.
And what is 3 of 9? Log base 3 of 9?
2.
2. So it's 2 times 2, which is 4. And everyone's like, well, I could just type that in. Yes, except they give you variables in the entire diploma and on unit tests, so you can't just type it in. K log base 2 of A can be written as log base 2 of A to the K. This just goes back through the rules again in a box so that you can see the rules. Then we're going to flip over. Okay, log base 3 of root 27. What is the square root symbol as an exponent? Do you remember? Log base 3 of 27 to the what? To the half. Remember, the square root is just a half as an exponent, because your exponent is a 1 and you take the index and drop it underneath, which is a 2. So whenever you have the square root, you can write it to the half. If you have it to the cube root, what could you write it as? 1/3. So now what I can do is I can just take that half and I can drop it in front, because I know log base 3 of 27. If I take the half in front, I can do this without my calculator. What is the answer to this? Log base 3 of 27. It's 3, because 3 to the power of 3 is 27, right? So now I just get a half times 3. Now, what is the 3 over? Because it helps you out to multiply these, because you guys multiply more.
1.
Over 1. And then we just get 3 over
2.
When you're multiplying fractions and you have a whole number, put it over 1. It won't make you not mess it up, because if you don't put it over 1, half of you will put it to the bottom as well. Okay, cool. I like number 2. I want to put them together. They're both base 2. Woohoo! I can put them together. And then I'm like, I can't put them together because I don't have what's in front?
1s.
1's. But how can I make myself have the 1's in front? Bring it up to the exponent. So I can go log base 2 of 16 to the half minus log base 2 of 8 to the third. Now what's cool about this? 16 to the half and 8 to the third are numbers. So So I get log base 2. What is 16 to the half the same as? It's 4. Because what does to the half mean? The square root. Anything to the power of a half is the square root. So if you go 16 to the half, it's actually asking for the square root of 16, which is 4. Minus log base 2. 8 to the third is 2, because instead of it being the square root, now it's the cube root. Now I can put them together. I know I could solve them, but I'm going to prove it by putting them together. Log base 2, what goes in the numerator? 4, because there's a plus 1 in front. What goes in the denominator? 2, because there's a minus 1 in front. So I get log base 2 of 2, which is 1. Could we have done it a different way?
Yes.
Could we have went 2 minus 1, which is 1? Yeah. All right. When they're all numbers, we can do them many ways. When we have variables, we don't have as much options. We actually have to try and put them together. Can I put these together? Log base 2, log base 2, log base 2, log base 2. I can put them as log base 2. Can I go right now and put them as log base 2? What do I have to do first? Bring this 2 that's in front to the exponent. And now it's a minus 1 in front. Can I now put them together? Yes. So I get log base 2. Anything with a plus 1 in front goes in the numerator. Anything with a minus 1 in front goes in the denominator, right? So, what has a plus 1 in front? X, the first one, and then the second one. And what I tell you to do if you have more than one term in the numerator? What operation do we do to these?
Plus.
We'll always multiply. Then we have minus 1, so the x squared goes in the denominator. And the y has a minus 1 in front, so it also goes in the denominator. And what do we do with these two things? Multiply. So now I have log base 2 of 2x squared over x squared y. Is there anything I can do still? Cancel the x squared. Because they're not sewn together by titanium. Remember that plus or minus sign? Sews them together, then you can't cancel off. These are actually multiplied, right? Multiplied is like a nice warm hug, like Olaf, you know? So we can cancel those off. And then we're left with log base 2 of 2 over y. Everyone following that? And people will leave it here. The catch is, the reason why the diploma questions are a little harder is sometimes they keep going. Can we keep going with this one? We can actually expand it back out again. And why would we expand it back out again? Because we're going to get log base 2 of 2, which is 1. So this might be the answer that's in the multiple choice, and then you stop there. Or the answer might look like this. Expand it back out. I'd get a plus 1 in front, log base 2 of 2, minus 1 in front, log base 2 of y. And what's log base 2 of 2? 1 minus log base 2 of y. This might be their answer. You have to have what they have. If they have it in a minus log b or log 2b, what's a and b respectively?
Would be one multiple choice, and both options are there because that's
Both options are correct, and both will not be there. Yeah. They can only put one version. Yeah. There's no such thing as better answer. It's just what is correct. So they can't put like 2 on there, because which one's better? I don't know, depending on the human. Either is better. They have to give you either a multiple choice answer that matches it, or they have to give you like a numeric response with like I said, this could be like maybe in the form a minus log base 2 of by, and then the value of a, b respectively would be 1 and 1, or the sum of a and b would be 1 plus 1, which would be 2. Like they have to give you a form. Yeah. Okay. Look at 4 and 5. There, your friends. Try them out. So here we have log base 2, because they all are base 2, base 2, base 2, base 2. Then I look for positive 1, negative 1, negative 1. So they're in the format that I can put them together, right? And so I'm going to get 2 in the numerator, because there's a plus 1 in front. 3 in the numerator, because there's a plus 1 in front. If there's more than one thing, I multiply. 6 in the denominator with a minus 1. 8 in the denominator with a minus 1. And so I get log base 2 of 6 over 48, which is just log base 2 of 1 over 8. 2 to what power is 1 over 8? 2 to the 3 is 8. So 2 to the what is 1 over 8?
-3.
Remember, negative exponents just get you that fraction. What's the problem with 5?
No 1 in front of your log.
Yeah. And what bases are these logs? 10. If I don't have a base, I immediately write 10, because when I see 2, 2, 2, 2, it screams, put me together. But if I don't see anything, it doesn't scream, put me together. It's just like, here it is. What do I do with it? So if I put 10, 10, 10, I'm like, log base 10, log base 10, log base 10. I'm like, oh, I'm not cheering. It just wants me to put them together, you know? Like if you feel like you're cheering when you're saying the logs, it's trying to get you to put them together. So we have to bring the 3 up here, which is what Taisei said, which is right, and then a half up here. So we're going to get log base 10. Do they have to write the 10 on the diploma? No, I'm doing it here to prove a point. It has a plus 1 in front, so a is in the numerator. Plus 1 in front, so b cubed is in the numerator. And a c to the half, which they might write as what? Nope. It would be c to the negative a half. But no, they'll leave it on the bottom. What would they maybe write it as, though, instead of c to the half? Square root of c. And then this one, they all have 1s in front. I can't see the diploma giving you all just numbers. You could plug them in, but whatever. We'll pretend it's the diploma style. And we'll put an 8 there. 16 goes in the numerator because there's a plus 1 in front. Minus 1 in front of this one, so 2 in the denominator. Plus 1 in front of this one, so 4 in the numerator. And so I get log base 8 of 64 over 2. Which is log base 8 of 32. I know it's not 2 or 4. Which one is it, A or B? B makes sense because 8 to the 5/3 is just the same thing as saying the cube root of 8 to the 5. What's the cube root of 8? 2 to the 5 is 32. 5/3. Then once again, I gave you the box of the rules again, in case you missed them on the other boxes of rules. I don't know why I'm doing it twice. Really drill it home, you know. And then we're going to flip over. You're going to do example 3, 4. Example 4 is 1, 2, 3, 4, 5, 6. Try them out. So if I expand this one out as base 10, I put a base on it if it doesn't have a base 10. So I go log base 10, this equals log base 10 of 100. These are all multiplied. So I put little multiplication dots to remind myself. Plus log base 10 of A, plus log base 10 of B squared. So this can drop in front, and I can get a 2 here. And what's log base 10 of 100? 10, yeah, 10 to the 2 is 100, so it's 2. Plus log A plus 2 log B. They won't write the 10s in your answer, just so you know. But putting the 10s will get you to do this correct, because people won't often see that log 100 is 2 unless they put the base 10 down there. Now this one here, you have 25 multiplied by m cubed. I always put little red multiplication dots or colored dots in there so that I remember to expand them. If not, people will leave it as 25 m cubed and not actually expand it further. So I'm going to get log base 5 of 25 with a plus 1 in front because the 25 is in the numerator. And then I go plus 1 log base 5 of m cubed and then I have minus 1 because of the n in the denominator, log base 5 of n, and then they can take this 3 and drop it in front. So we get, and what's log base 5 of 25? 2 plus 3 log base 5 of m minus log base 5 of n. So it's C. So if the square root is to the half and the cube root is to the third, the b roots would be to the what? What would the b roots be to? If the square root is to the half, the cube root is to the third, the b roots would be to the 1 over b. So we can know that the answer is 1 over b by that rule, or we could say, hey, now that I know the power rule, I can actually drop it in front. So 1 over b, and then beside it is log a of a. What's log a of a just the same as? 1. So that's why you actually get 1 over b. But you can just remember the rule of log a to the 1 over b is 1 over b, right? This one they all have base x, base x, base x. So I raise this to the 3. I don't do anything to that one. I raise this to the quarter. And I get log base x. 4/3 goes in the numerator because it has a plus 1 in front. 8 goes to the numerator and gets multiplied because there's a plus 1 in front. 16 to the quarter goes in the denominator, because it has a minus 1 in front. So I'm going to get log base x, 64 times 8. What's 16 to the quarter? It's the 4th root of 16. What's the 4th root of 16? It's a 2. Uh, 64 times 4, what's that, 512? No, 256? 512? Divided by 2, is that 256? This one is a essential one to look at too. We get log base A. If I have 5s and 3s, I can make 7s and 8s. 75 is actually 5 times 5 times 3, is it not? Because it's 25 times 3. So I need to make it in these forms. This comes up on diplomas all the time, just so you know. So you get log base A of 5 times 5 times 3, because I need 5s and 3s. That's what this says. And then times A squared. And then I expand that out. I get log base A of 5 plus log base A of 5 plus log base A of 3 plus log base A of A squared. This actually works out to something really nice. What can I replace log base A of 5 with? 7 plus log base A of 5, 7 plus log base A of 3, 8. And then A to the A squared is 2. So I actually get 22 plus 2, 24. I'm going to go down to this one. These would be division, because you have one of these in your homework. So this would be log base 10 and base 10, so it screams put me together when you have the 10s. The top has x squared minus 4. The bottom has x minus 2. What you have to spot is x squared minus 4 is a difference of squares. So it gets you x plus 2, x minus 2 over x minus 2. So it kind of uses rationals of grade 11. These cancel, and I just get log of x plus 2, which is a. The top one's just multiplication, so you would end up with b. Your homework